Hello everyone. Today's joke of the day is, what do you call a bear with no teeth? Stay tuned to find out. Our learning target for today is, I can construct and interpret a stem and leaf plot. Okay, so a stem and leaf plot is a type of plot that we can use to represent a data set. Okay, so we are going to use the pulse rate data to make a stem and leaf plot. Now, in order to make a stem and leaf plot, we have to set it up like a little table kind of. So I'm going to write over here, I'm going to write stem, and then I'm going to draw a line, and then a little bit longer side on the right side here, and I will write leaf. Okay, so we're going to have our stem on the left-hand side and our leaf on the right-hand side. And what's actually going to happen is the stem is going to be the list of all the numbers in the tens place, and then the leaf will be the ones place numbers. Okay, so for example, we look and we want to start with our lowest number. Okay, the lowest number in our data set is 63. So we put a 6 on the stem side, and then we'll put a 3 on the leaf side. Okay, so that represents the number 63. Okay, and now the next lowest number we have is 65. So instead of writing the 6 again, we're just going to, next to the 3, we'll leave like a space. We're not going to put a comma or anything, but we'll write a 5. Okay, so now we know that our data set has the number 63 and the number 65. Okay, our next number that has a 6 is 68. Okay, and those are all the numbers that start with 6, okay, that are in the 60s. So then we will move on and we'll make a new stem with our 70s. So our next stem will be 7. And we have a 72 and another 72 and then a 74 and a 75. Okay, and that's all of our 70s, but we also have some 80s, so we'll make an 80 stem, an 8 stem. We have 80, so 80, that's the lowest, and then 82, 84, and 88. And finally, we have 90, so we'll make a stem, a 9 stem, and then 0 is the leaf. Okay, so this is all of our stem and leaf data. Now, the important thing when you are making a stem and leaf plot is to make sure you include a key. Okay, so the key tells us how we read our stem and leaf plot. And you can pick any numbers. I'm just going to pick a number that's in our data set. I'm going to say 63. Okay, and if I have 6, and then I make my little bar, and the 3, so this represents 6 is the stem, and then 3 is the leaf, I want to say that that is equal to 63. So that anyone looking at my plot knows exactly what the numbers are. So this tells me that 6 and then a bar and 3 is going to be equal to 63. Okay. Now let's use this stem and leaf plot to answer some questions. What is the highest pulse rate? Okay, well that's going to be our biggest number, and as you can see, our stem and leaf plot, we go from our 60s all the way up to the 90s, and the 90s are going to be our highest pulse rate. So our highest pulse rate is 90 beats per minute, or BPM. Okay. Then we also want to look and figure out what is the median. Okay, so we're going to figure out the median by crossing off numbers, right? So like we have 90 as our max and 63 is our min. Okay, and they're already in order from least to greatest. So we will just make sure we cross each number off with another number, right? Its partner. So then I'll do 88 and 65, 84 and 68, 82 and 72, 80 and 72. Okay, and then we're left with the number 74 and 75. So our median will be the number that is right between those. So we'll take 74 plus 75 and divide that by 2. And that will tell us, that gives us 74.5 beats per minute is our median pulse rate. Okay. All right, let's construct another stem and leaf plot. The list below shows the number of stories of some of the tallest buildings in Houston, Texas. We're going to use the data to complete the stem and leaf plot. So we'll set up our stem and leaf plot. We'll take our stem here, and then our leaf over here. Okay. And we'll start with our lowest number, which looks like it is 36. Okay, 36 is our lowest number. So our stem is 3, and then our leaf is 6. We actually have another 36 as well, 2 36s. And that looks like it's all for the 30s. And then we have some 40s. So we'll make a stem of 40. And it looks like the lowest one is 42. And then we have a 44. Also 45. 46. And another 46. Oh, those are a little bit close. So I'm going to make sure that I try and keep them evenly spaced. 47 and another 47 and 49 and another 49. Okay, so I'm going to fix this one a little bit just quickly, just to make sure our spacing is even, because that makes it look nicer, right? And I'll make my leaf side a little bit longer there so it includes all of the data points. Okay, and then let's move on to the 50s. Looks like we have a 50 and another 50. And then we have a 52, a 53, a 55, and a 56. I'm going to rewrite this 5 so it looks a little nicer there. Okay. And then we have a 64, and that's our only one in the 60s. And then we have a 71 and a 75. Okay. And that's all of our data points. So our full stem and leaf plot has been made, except we just need to remember to include our key. And I'm just going to pick any number. I'll say 44. So 4. Oh, that's a bad one. Don't use 44 because then you don't know for sure which way things are read. I'll do 47, okay? And we'll say that is equal to 47. Yeah, 44 would not be a good example, or any number that's repeated like 55 or something like that, because you wouldn't actually know which way you're going to be reading it. Okay, so we don't have to answer any questions about that one, so let's move on and let's see if we can read this back-to-back stem and leaf plot. Okay, so in this stem and leaf plot, we have numbers on both sides that represent different data sets. Okay, this middle part here, this is still the stem. So maybe I'll label that really quickly. It doesn't have that labeled there, but this is the stem. Okay, and then the sides are the leaves. And each of the leaves are a different data set. So like this is the data set for all of the afternoon humidities, the relative humidity. And then this is the data set for the relative humidity in the morning. Okay, then we'll read our key here, and the key will tell us that 8 bar 7 is actually going to be 78% when it's on the side, the morning side, and then on the other side, 5 bar 3 is going to be equal to 53%. And actually, maybe I will do these in the respective colors so that you can see that this is how those ones are read, and this is how these ones are read. Okay, so it's very important to include a key so that you know how to read the graph or the plot. Okay, so what is the highest morning relative humidity? So we're going to look at the morning side, which is the left side over here, and it's going to be 80, right? The 8 is the biggest, and 89. 89% will be our highest morning relative humidity. And then we want the lowest afternoon relative humidity will be 51%. Again, those numbers in the middle are our stems. Does the relative humidity tend to be higher in the morning or the afternoon? Well, if you look at it, our numbers are listed from least to greatest. The afternoon is all like in the 50s, and the morning ones are in like the 70s and 80s. So it's going to be higher in the morning. Okay. All right. So what do you call a bear with no teeth? A gummy bear. Thanks for watching, and have a great day.